We've gone over circles, we've gone over ellipses, parabolas, all that good stuff. So now we'll be learning about hyperbolas. Hyperbolas. And so what is a hyperbola? Well, like your circles, ellipses, and parabolas, it's a type of conic section. So let's draw our cone. And how can we cut this cone to make a hyperbola? Well, it looks something like this. It'd be a vertical plane that cuts straight down one side of the cone. And let's draw our curves. So there would be one about here and one right here. And as you can see, this is our hyperbola created by the cone getting cut by this plane. So now let's put this hyperbola onto an actual coordinate plane. So this one that we drew here is a vertical hyperbola because there's one curve on top and one on the bottom. So it would look something like this. And the other type is the horizontal hyperbola that would have a curve on the left and a curve on the right. Horizontal. And now before we move on to standard form and general form, stuff like that, let's point out the important parts of a hyperbola. So let's use one set for now to make it simpler. So the 2 points, like the 2 turning points, hyperbola, there's one here and one here. Those are called the vertices. And the line that connects the vertices, right here, that's called the transverse axis. Okay, the next part of the hyperbola are the asymptotes. The asymptotes are the 2 lines that the hyperbola will infinitely approach but never touch. It would look something like this here and this here. So those are the asymptotes. And the point where the asymptotes intersect, right in the middle here, that's the center of the hyperbola. So the last really important part of the hyperbola you need to know for now are the foci. And these are a bit harder to understand. It took me a while, but basically, and these are 2 points inside the curves. If you pick any point on the curves of the hyperbola, let's say I pick this point, the difference between the distances from this point to the first foci and this point to the second foci will always be the same. So let's draw that to visualize it. So this yellow distance minus, let's do green, minus this green distance will always be the same, or the other way around. So let's say this green is D1 and the yellow is D2. D2 minus D1 will always be the same. It will be a constant. And it doesn't matter which point on the curve you pick, it's always going to come out to this number. And you should add an absolute value around these because it's the distance. It doesn't matter if it's positive or negative. So yeah, to sum it up, the foci are the 2 points where the distance from one of them to a certain point. So that's what foci are, basically. The difference between the distance of one foci to a point on the curve and the other foci to the point of the curve will always be a constant number. And it doesn't matter where on the curve I pick. I could have picked here, here. It would all come out to this constant. It looks something like that. And a horizontal hyperbola's standard form. Horizontal would look something like this. So let's take a look at the standard forms of the vertical and horizontal hyperbolas. How can we tell if a hyperbola is vertical or horizontal by their standard form? Well, if you look here, in the vertical standard form, the y expression with the y is positive, and there's a negative sign in front of the x. While in the horizontal hyperbola, the x is positive and the y is negative. So that's how you can tell. And you may be wondering, what are these letters? What is this A, B, K, and H? Well, let's draw a new hyperbola graph. So this time I drew a horizontal parabola to change it up. So this is for the horizontal hyperbola. And let's start with this A. What does the A mean? Well, the A is the distance from the center of the hyperbola, which is right here in green. The distance from the center to the vertices of the hyperbola. So this distance from here to here and here to here, that's A, and that's A. So that means the length of the transverse axis, which is this whole part, would be 2A. The B is a little more complicated. You have to match this vertex, draw a vertical line to the asymptotes, like this. And the B would be the distance from the center to the top of this box we have. So this would be B from here to here, and this would also be B from here to here. As for this H and K, they're very important in determining key points in the hyperbola. For example, the point for the center is just HK. And this point determines where the hyperbola is on the coordinate plane. And it's also used to find the vertices, because when the center shifts, the entire graph shifts, which also shifts the vertices. So the formula to find the vertices in a horizontal hyperbola, for the first one, it would be h plus a k. And for the second one, it would be h minus a k. The vertical hyperbola, it's very similar, but you just add the a to the k and subtract the a from the k. So it would be h k plus a, and h k minus a. Let's come back to foci really quickly. Now that we know our standard form and what a and b stand for, we can figure out the exact points of where the foci are. So the foci, the formula is for a horizontal hyperbola, h plus c k and h minus c k. And for a vertical hyperbola, it's h k plus c and h k minus c. So how do we know what c is? Well, we just have to do a squared plus b squared equals c squared. So if we know what a and b are, we can use this to find what c is. And when we find what c is, we'll just have to add or subtract it onto h or k depending on if it is a vertical or horizontal hyperbola. Now moving on to the second form, the general form. General form. The general form is a lot harder to deal with and doesn't really tell us much. So that's why we usually try to convert it into standard form. So how do we do that? Let's do an example problem. So how would we put this expression in general form into standard form? Well, let's take a look at the numbers here. We have a 9x squared minus 18x. We can factor a 9 out of that. So 9 times x squared minus 2x minus, we can factor out a 4 from the y's, 4 times y squared minus 4y. And then we can move the 43 to the other side, equals 43. So now we can complete the square. What does this need to be a squared expression? Well, it needs a 1 inside the parentheses. So if we add a 1, that is now a squared expression, but because there's a 9 outside, we're actually adding 9. So let's subtract 9 on the outside. And minus, what would we add here to make this a squared expression? Well, we could add a 4 plus 4. And since there's a 4 here, we would have to add 16 this time because we're subtracting this, equals 43. So now we can simplify. And now we just have to divide 36 on both sides. And that would give us x minus 1 squared over 4 minus y minus 2 squared over 9 equals 1. And there we have our standard form where we can get all the information we need. So now let's talk about the major axis of a hyperbola. Major axis. And we actually already talked about it, but under a different name. The major axis is the same as the transverse axis, which is from one vertex to the other, and it has the length of 2a. And the minor axis, it's also called the conjugate axis, and it has a length of 2b. Okay, let's do a practice problem, and let's find the vertices, center, foci, major axis length, minor axis length, all from just this standard form hyperbola equation. So let's start with the vertices. Let's find the a and the b. So the a, that's 16 is a squared, so a would be 4, and b would be 2. The h would be 2, because it's x minus 2, and the k would be 1. Let's find the center first, since that's the easiest. It's just hk, so the center is 2, 1. And to find the vertices, since it's a horizontal hyperbola, since this x is positive here, we just have to add and subtract the 4 to this x value of the center. So adding 4, we would get 6, 1, and subtracting 4, we would get -2, 1. So that's the vertices and the center. To find the foci, we need to find the c value, which is a squared plus b squared equals c squared. So 16 plus 4 equals c squared. C squared equals 20. So c equals 2 root 5. That means the foci are at 2 root 5, 0, and -2 root 5, 0. And the major axis length, like we said earlier, is just 2a, so that would be 8. And the minor axis length would be 2b, which is 4.